we'll start mechanical properties of fluids or properties of fluids. So here this topic is divided into three. Okay, fluid. Okay, fluid. Okay, mechanical properties of fluid. This is divided into one, static fluid, two, dynamic, third one, surface tension. Okay, static fluid, dynamic fluid and surface tension. Static fluid, we deal with the fluid which is at rest. Okay, if we take water in the beaker or water in the water bottle, all these are static fluid. Dynamic fluid means water which is flowing. That flow will be of two types actually. One is streamline flow. Streamline flow means very disciplined, very நிம்மதியோட ஓடிட்டு இருக்குது. ஓகே, நல்லா இருக்கும். ரிதம் சாங் இருக்குல்ல, தீம் தனா தீம் தனா, அதே மாதிரி. ஓகே, that is what is dynamic fluid streamline flow. Turbulent flow இருக்குது, இப்படி எல்லாம் வந்து சுற்றி old pool, everything will be there. Turbulent flow, we don't study that. Okay, last one is surface tension, the force between fluid molecules and other molecules. All these things we will discuss here. So we will start with the dynamic fluid. Okay, hello, no, static fluid. We will start with the static fluid. So here we do some assumption about this. We are considering ideal fluid. Okay, ideal conditions we will keep. Ideal conditions we will keep, then we study. So ideal fluid, one thing we think that it is incompressible. This is incompressible. Okay, then it will have same density and no friction. No friction, that is no viscosity. Okay, we are considering non-viscous fluid. Okay, so we consider these things. Okay, and density, generally what will be there, these points will be, we may not feel much difference. Okay, இப்படி இருந்தா என்ன, we may think like that, but those who have knowledge, no, they will think bit worried here, because density of water will be different at different places. That happening could be there. Viscosity can be there. Okay, salt water, normal water, all those differences we are just neglecting and we are studying. Okay, so this is the first thing. So very first thing which we need to understand is about, okay, so what is pressure? So you can interact with me. Okay, what is pressure? Okay, what is pressure? Area. Suppose if this is area, okay, if I apply a force like this, then what is pressure? Force by area dane. Yaar kedach manavali kadippu oruga, someone is angry, someone feeling enna marudim force by area, that's problem irukudha. Is there anything wrong if I write again, okay, this is the force at an angle 30 degree, P is equal to F by A. Correct தானே? அப்படி எழுதலாமா? இப்போ சீக்ரெட்டா இப்படி காமிக்கணும், எழுதக்கூடாதுன்னு சொல்லி இப்படி காமிச்சோம். Okay, if someone wants to say எல்லாம் நான் பெரிய ஆள்னு மற்ற யாருமே தெரிய வேண்டாம், எனக்கு நிம்மதியோட வாழ்ந்தா போதும், I need to live peacefully. If you have some feelings like that, then what you need to do? இது சரியா தவறா? Okay, if I ask that, what you can do? இப்படி காமிச்சா போதும், ஒரு கண்ணு மட்டுமா அடைக்க வேண்டாம், just both. Blink both. Okay, so is it correct? No. நிறைய பேர் இருக்கு இப்போ. Okay, so we resolve this vector. How to resolve, papas and puppies? Hope everyone might be resolving vectors into horizontal and vertical. One has a problem in that, then it is just like you do not know ABCD. Okay, so if problem is there today itself, you should correct it. Okay, so fine. So if a vector is acting like this at an angle theta, this is what? Venda. Okay, this is acting at an angle theta like this, then what is this? A sin theta, and this is a cos theta. In the what a cos theta so theta alla clear da? Okay, sure, good. Sans we resolve this will become what? This will be f cos theta. So generally if we apply like this, if this platform can move, it can move in this direction. So this is moving horizontally as well as vertically. So in order to separate that effect, we are resolving this. So pressure is equal to force by area. When I said, you have decided, okay, you yourself have said this is nothing but sin theta. So this force is nothing but force perpendicular. Okay, so pressure is equal to perpendicular force by area. Perpendicular force by area. Clear? Right. So then pressure is vector. Pressure is a vector. Pressure is எல்லாருக்கும் தெரியுதுனால யாருமே பேசுறது இல்லை. Okay, pressure is scalar. Pressure is scalar. SI unit is what? Pascal. Okay, Pascal. Another unit what we use is atmosphere. Okay, Pascal. This is SI unit. This is SI unit. So one atmosphere is how much? 1.0 Pascal. 5 Pascal. Okay, then another unit which we normally use is what? Just like say for example 76 mm of mercury. Okay, this unit used, right? 76 centimeter of mercury, the height of mercury column. Height of mercury column, this we will discuss in when we see barometer. Okay, so height of mercury column. Height of mercury column. So these are the common units which we use. Clear regarding pressure? Okay, when I say pressure is scalar, one word I would like to use is isotropic. Isotropic means direction in every, okay, application in every direction. That is what is isotropic. Suppose if this is water, okay, idukulla enna irukudhu? Water. Okay, so if I try to find the pressure at this point, the pressure will be acting in all the directions. Okay, suppose if I consider this point, pressure will be acting in this direction. If I consider this lower floor, then this will be acting in this direction, here acting in this direction. So pressure is isotropic. It will act in every direction. It will act in every direction. Okay, so suppose if I consider a point like this, okay, when I am showing direction, pressure is isotropic means actually what I should infer, the force will be acting in every direction. More precisely, force will be acting in every direction. Okay, clear or what? Because of pressure, force can act in all the directions. Clear? Okay, right. Now next heading you can put variation of pressure vertically with depth. Variation of pressure vertically with depth. Variation of pressure vertically with depth. Vertically with depth. That is, suppose we take a beaker. This is full of water. Okay, now in order to understand the pressure difference between points, first thing which we need to understand is this is open to atmosphere. This is open to atmosphere. So atmospheric pressure, which we denote as P0, will be acting always here. Okay, P0 will be acting always here. Suppose if we consider a liquid column, okay, just I will mention in the way you understand. Okay, if we consider a liquid column, okay, liquid taniya mari nikkiradilla, liquid is not separately standing like this, but we are considering a liquid column. Then you could understand that whatever force in this direction, the same force will be from this direction also. So this force and this force will be cancelled each other. Okay, but here what will happen? Here pressure will be there. Because of this pressure, there will be a force on the bottom. Because of that pressure, there will be a force on the bottom. Okay, now if this is P0, we could say that here the pressure is P. Here the pressure is P. Suppose if the height of this liquid column, is H, and density of this liquid is rho, okay, and acceleration due to gravity is G, then I could say that this pressure, okay, pressure due to this much fluid will be H rho G. Okay, and I could say that this pressure P is nothing but P0 plus H rho G. Okay, so the difference in pressure is what is H rho G. Okay, the difference in pressure between these 2 points. I repeat. Okay, suppose there is no atmosphere. Okay, but what is there? Water is there. Acceleration due to gravity is also there. When acceleration due to gravity is there, definitely atmosphere will be there. But for your understanding, okay, if just forget this one. Simply if you go down, what will be there? The pressure you will be experiencing here will be H rho G. So what I am doing is, you are going to dive. Okay, all are there. Okay, this side gulls, this side buoys, okay, all are there. We are going to, I am your diving master, I am going to jump. Okay, jump solidu neenga dhaan chaadu, only you will jump, I will be there on the side. So before jumping the diving master side, you can go up to 10 meter, don't go beyond. Okay, so what is the problem? Then he said, till a height your body can maintain that pressure. Okay, after that you won't be able to do. So one person who can keep the breath, he jumped, and what he is doing is he went down up to 1 meter. Then he saw pressure is equal to 1 rho g. Again he went down 2 meter, 2 rho g, 3 meter, 3 rho g, 8 meter, 10 rho g, 8 rho g, correct? Going beyond, it will become 10 rho g. After that, your lung capacity, we are not Avengers, no, we are not Thor or Thanos. Okay, our lung is normal human lungs, right? Even corona can damage it. So avlo lesana valare anbana cute lungs we have. So beyond 10 meter we understood idukullaye, even in this height I am not able to handle. So what you will do? You will come up. So those who do scuba diving, they will have an instrument with them, and they will be doing what? They will change the pressure. Will keep something, no? So they will balance the pressure. So lung, the pressure should be balanced, then only you will be able to go further height. Otherwise pressure will be more. Pressure will be more. So pressure is equal to what? H rho g. Now along with that, if atmospheric pressure also comes, what will happen? Total pressure will be P naught plus H rho g. This is atmospheric pressure. Okay. So this P is called absolute pressure. Absolute pressure. This is called absolute pressure. This is called atmospheric pressure. This is called gauge pressure. Okay. So pressure is equal to H rho g. Okay, always. Okay, see, you have studied about what free body diagram. You have studied free body diagram. You have studied, no? Free body diagram means what? If free body diagram on me means what? The force acting on me, or I should consider force act by myself. In free body diagram, should I consider the forces acting on me alone, or should I consider, suppose, see, okay, how much is this force? F is equal to 1 Newton. F is equal to 1 Newton. mg is also there, no? I may have some 60-65 kg of weight. So okay, mass. So 65 into g you can consider maximum. Okay, mg is there. I am applying force here, 2 Newton. So 2 Newton and mg both I should consider, no? According to free body diagram. Yes or no? இவரோட free body diagram அது அப்போ கன்சிடர் பண்ணக்கூடாது. அது சொன்னா போதும் இல்லை, அது என்ன திட்டணுமா சும்மா? ஓகே, கரெக்ட், பர்ஃபெக்ட். ஸோ ஃப்ரீ பாடி டயக்ராம் மீன்ஸ் we should consider only the force on that body. Okay, now free body diagram for force, not for pressure இல்லையா? So suppose if we take this liquid coil, okay, I kept it here. Okay, so this is the body. Okay, due to atmospheric pressure, P naught into A acting downwards or what? Correct? Okay, then mg will be downwards, right? Now this pressure will be acting upwards, P into A. The area of cross section of this, suppose if we consider as A, we could write that the force downwards, this liquid column is static fluid, this is static fluid allava. Okay, so here this is in equilibrium, we can consider, no? Net force will be 0, upward downward force will be 0. Okay, so downward force is P naught into A is plus mg is equal to what? P into A into A. So P naught into A plus what is mass? Volume into density. So volume into density into G. So can I write this as A into H? A into H into G is equal to PA. Correct or what? Mass is equal to volume into the density. Volume is nothing but area. Okay, so namakku oru P naught. Okay, so that is how this formula comes. P is plus G. Okay, so Newton's laws of motion. Okay, the application of that. Free body diagram is nothing but all the forces acting on that body we will be writing. Nirish Tangam, Chellam, understood or what? Free body diagram. ஞாபகம் இருக்கா? எதுக்கு இப்படி போய் சொல்லிட்டு இருக்கீங்க? இப்படி ஆட்டிட்டு இருக்கு. கிளியர் தானே? கிளியர் நோ? அண்டர்ஸ்டுட்? ஓகே, ரைட். நான் இப்படியெல்லாம் ஓட்டும்போது உங்களுக்கு கோபம் வராதில்ல? நீங்கள் கோபம் இருந்துச்சுன்னா கிளாஸில் இருக்கும்போது என்ன எதுவும் சொல்ல வேண்டாம், செய்ய வேண்டாம். ஓகே, வெளியே போகும்போது ஆஃபீஸில் என்ன டீல் பண்ணிக்கலாம். சார் நீங்கள் அது சொன்னது எனக்கு பிடிக்கலன்னு சொல்லிட்டு நான் பேசிட்டு கொண்டு போய் டீயெல்லாம் சாப்பிட்டு டீயெல்லாம் கொடுத்து செட்டில் பண்ணிடுறேன். ஓகே, இன்சைட் த கிளாஸ் என்ன மிரட்டக்கூடாது, சரியா? ஐ ஆம் வெரி வீக் ஹியூமன். கிளியர் ஆர் வாட்? ஃபைன், ரைட். ஸோ yesterday itself we have seen, gentlemen, you have asked, like how this comes equation of straight line. So again, see this one, is it an equation of straight line? Can you relate? Who is the variable here? H. Rho G all are constant. Okay, so equation of straight line y is equal plus c. Equation of straight line தெரியாதவங்க இப்ப படிச்சுக்கலாம். No need to think that you do not know. So what I do, if draw a straight line, this length is what? C. This is called intercept. Okay, intercept. The slope of this m, which is nothing but inge enna irukum, this is x, this is y, so this is going to be x2 comma y2. அங்கே அது வெளியே அவர் திட்ட முடியாதுல்ல, எதுவும் பண்ண முடியாது. Okay, so this is going to be x2, this is x1, this is nothing but y1, so this is going to be x1 y1. So slope is equal to m. If this is theta, either we can write tan theta or what? y2 minus y1 divided by x2 minus x1. So this is what is slope equation of straight line. Very simple. M into, so y inga y axis, x inga x axis, m is slope, c is intercept. Same. So when I plot, okay, so இது p, y, so p, so variable h, x, h. So இங்க c தனியா ஒரு நாள் நின்னுட்டு இருக்குல்ல, is p naught. So here this is going to be the pressure, p naught. Okay, so h என்ன ஆகுது? h is linearly varying. So என்ன பண்ணலாம்? Okay, what is the slope of this? Slope is equal to enna papas and papis? Rho g, chance illa. Okay, so if you get that graph, okay, suppose if they give graph ரொம்ப twist எல்லாம் பண்ற மாதிரி இருந்தா we will be able to deal it, right? Fine. So if this is theta, slope is tan theta. Okay, that is also fine. Okay, so suppose if I consider 2 points, what is the pressure difference between them? H rho G. H will be this difference in height. Okay, so between 2 points, whatever be the distances or height, we can take like a H rho G. Clear or what? Right? Okay, done? Fine. Now, variation of pressure horizontal. Variation of pressure horizontally with the length or whatever it may be. Suppose if you consider a beaker like this. Okay, if you consider a liquid column, okay, there be any pressure difference? முன்னாடி வந்து mg was acting here. Is there what all forces are acting in this? இப்படி there will be a force. If this area of possession is A, then this is going to be PA. This is also what? PA. இப்படி mg act ஆகும்ல? ஆகாதுல்ல? ஆகாது. அப்ப எப்படி pressure difference வரும்? Pressure difference வராது. So there is no pressure difference. இப்படி ஒரு length போட்டாலும் சரி, what? There will not be any pressure difference horizontally. Okay, remember this. There will not be any pressure difference horizontally. Okay, that's it. நம்பர் கொஞ்சம் சைலண்டில் வைங்க. கிளாஸில் இருந்து இருக்குதுனால அவர்கிட்ட சொல்ல முடியல, இன்னும் அந்த அனுப்பிட்டு இருக்கிறவர்கிட்ட. ஸோ நம்ம அந்த மெசேஜ் வந்துட்டு இருக்கட்டும், பரவாயில்ல, நமக்கு we can read. கரெக்டா? ஸோ சப்போஸ் இஃப் we do so okay, suppose if this is the length and this is the height. Okay, so if this is P1, this is P2, what is P2 pa? Same fluid, rho. What should I write? P2 is equal to what? P1 plus do you rho G? Okay, this is wrong. This is wrong. Okay, we need to consider only the vertical height. Why? Because suppose if I consider this length, then suppose if we consider this as H1, then the pressure is going to be P intermediate, okay, is equal to H1 rho G. Then you go to bend varudilla. Suppose if we consider this, here the pressure difference is 0. So again if we take this one like this, okay, this is going to be H2. Then what we need to consider? P2 is equal to H1 rho G plus H2 rho G. Okay, so H rho G. So that vertical change, twist, all these things we need not consider. Clear? Fine. Okay, so if this is B, this is C. So the pressure, which one will be in what order? Same. If we do like this, some options, what will be the answer, children? Same. Okay, same. Content is there, that doesn't matter. Okay, only that vertical height we need to consider. Fine. So answer will be EA will be equal to PB is equal to PC. Clear? Okay, next one, right, three vessels having equal base area are filled with equal volume of water. Okay, equal volume of water. So same base area filled with the equal volume of water. Okay, fine. Okay, so this is A, B, C. So same options. PB greater than PC, PA greater than PB, PB greater than PA greater than PC, PC. Which is correct? B. Any other answer? Interact. No worries. Papa, you came today for the first time. Your good name? No need to stand up. Just sit and say. Merlin. Okay. Okay. Sudarshan avargale, what is the answer? Thing is, base area is same. Base area is same. Base area is same. Another point is equal volume of water. So what will be the answer of this? Easy. B. If this is the thing, then when we reach a little bit of height, what will happen? Okay. Here this is less, no. So after moving some height only, this will have equal volume. What about this? This is, so max water is here, max of water will be here. Correct or what? Option, which one? C. Which one? B. Yes, C. You see how, which one? Pressure in C will be more because same base area. Here this volume is increasing, so this will occupy more water. So here whatever height this is going to be almost level. Correct? Fine. Next question. Fine. Next one is equal mass of three liquids. Equal mass of three liquids A, B and C are kept in three similar vessels. Okay, rho A is greater than rho B if it is greater than rho C, then rho C. Similar vessels. Okay, so A, B, C. The question is again same options. Okay, this is equal mass of three liquids. Equal mass of three liquids A, B, C are kept in three similar vessels. If density of A is greater than density of C, then what will be the pressure? Same means D. D is the answer. Any other answer? A. Any other answer? Discussion, children. Discussion must be there. Discussion must be. If you have any other response, please tell. So mass is same. Mass of A is equal to mass of B is equal to mass of C. What? So mass of A is what? Volume of A into density of A, volume of B into density of B, volume of C into density of C. Right. Similar vessel done. They are all similar vessel. So I could write that area are same. Area are same. This is going to be area into height. Area into height. Height will be height of that water column or liquid column. Correct or what? Height of liquid column. So this is volume into rho A. This is going to be height of liquid column of B into rho B. This is height of liquid column of C into rho C. Correct? Rho C. So here to will be cancelled. And what they are saying is density of A is greater than density of B is greater than density of C. But this is equal. So what should happen? Height should compromise it. Height should compensate the change in density. When one density is increasing, height will be decreasing. Understood or what? If the mass is same, what will happen? Generally the height will be shrinked, correct or what? So that is what, clear? So height will be same, not height, actually this problem, the product of h rho is equal to constant when mass is same. Okay, h rho is a constant when mass is same. So the answer is D. Aslam avargal sonna madri. Okay, clear? Any confusion? Edachum manavali? No worries? Right. Okay, this is a beaker full of water. 3 points are given, A, B and C. Same options. What is the answer? B. D. Any other answer? These are the option. This is the question. Pressure at different points, A, B, C. What will be the answer? கருத்து வேறுபாடுகள் இருந்தா சொல்லுங்கள். அஸ்லமர் அவர்கள் சொல்லியிருக்காங்க D. சொல்லிவிட்டீர்கள் D. What is your answers? Same தானே? அன்பர்களே, பாப்பீஸ் சொல்லுங்க. முகேஷ் பாப்பி வந்து ஏ சொன்னாங்க. ஏ மார்க் பண்ணுவா. None of the answer is D, Thangams. And pressure at C, all will be same. The problem is here, the normal reaction of this will act here on itself, but will be acting. That normal reaction will compensate the difference. If there is pressure difference, what will happen? The flow of the fluid will happen. If the pressure in this here, if pressure here is more, what will happen? This pressure will flow. Not pressure, the fluid will flow. If the pressure here it is more, what will happen? The fluid will flow and they will maintain the pressure equal. Okay, so because here normal reaction is there, suppose if this pressure is more, what will happen? Water will flow. Okay, so finally the only explanation that we can give here, it is this normal reactions is enough to make this pressure at these 3 points as same. Okay, so again the answer is D. Another question. Okay, a glass of water, a glass of 1 liter volume base area 10 square and top area centimeter square. Okay, density of the fluid, okay, density of the liquid is 10 raised to 3 kilogram per meter cube. So this is also given. Okay, started. Okay, so this figure is also given. This is the shape of the figure. This is of height 10 centimeter. Okay, base area is 10 centimeter square, top area is 30 centimeter square. So density of the liquid is 10 raised to 3 kilogram per meter cube. Okay, so find the force. First question is find the force on the bottom of glass. 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 What is the answer? Okay, so here this is the pressure at the bottom. Okay, E is equal to what? P naught plus H rho G. So the atmospheric pressure we can take 1.01 into 10 raised to 5. Height is given, so 10 into 10 raised to minus 2. Density is given 10 raised to 3. Gravity we can take as 10. Correct or what? Fine. So how are we getting this 1 cube into cube, correct, plus what about this one? This one can be cancelled, right? So this is going to be 10 cube alone. So 102 what? Into 10 raised to 3 Pascal or 102 kilopascal. Clear? Adjust like that. Okay. Question is, so this is the first question. Okay, is it clear? Force. Then okay, this 10 centimeter square area how to multiply, right? 10 raised to 10 into 10 raised to minus 2. Okay, so 10 into 10 raised to minus 4. 10 raised to minus 4, right? So how much will come? 102 Newton, right? Fine. Second part of the question, find the force on water by sides of the glass. Find the force on water by sides of glass. Okay, done. So this one you understood. Shall I erase this? Okay. Can anyone tell that? how much the sides of the glass will apply force on the water. Okay. Any answer? Please tell if you get the answer. The force by the side walls on water. Certain questions we may not get idea, but what we should do? We should start marking the forces. We should start marking the forces. When you start marking the forces, we will understand that this is how we should proceed. So what I do here is, the force will be, see, the force by the glass on the water will be in which direction? Normal force is what they are asking, right? Normal force by the wall of the glass on the water, correct or what? This is what they are asking. Correct. Now if I take like this, I can resolve this into this direction and this direction. Exactly. If I take, I will get this direction, this direction and this dir. Okay, so what we understand, all the horizontal forces will be cancelled. Patak, 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 patak. So the force due to side walls on water, everything putting together will be in upward direction. Will be in the upward direction. Clear? Clear? Now mg will be in the downward direction. Mg will be in the downward direction. P naught into upper area will be in the downward direction. Now this base will apply a force on back on water. Okay, so that will be what? That pressure H rho. Okay, so now some forces are on the upper side, some forces are on the towards the what, ground direction or downward direction. So right, now what we get? P naught A upper then plus mg is equal to P into A lower plus what? Force due to side wall on water. Okay, what is this force actually? What note? Mg P naught A upper also we know, so find it out. Okay, so to solve this, we'll be getting the answer. So atmospheric pressure into A naught 1.01 into 10 raised to 5 into 30 into 10 raised to minus 4 plus mass is given, volume is given, no, 1 liter volume, 1 liter volume is given. So here mg is, we will have to do using volume. So mass is V rho g, mass is V rho g, correct? No, mass is equal to volume. Volume is 1 liter, means this is nothing but 10 raised to minus 3 meter cube. 1 liter volume is not SI unit. 1 liter volume is not SI unit. 1 liter volume is 10 power minus 3 meter cube. 10 power minus 3 meter cube. Density is given as 10 raised to 3 into 10. So mg what will be getting ultimately 10 Newton. So this is 10 Newton. Minus PA lower will be what? 102. Solve this, how much we are getting? Solve பண்றது கஷ்டம். 211 Newton. 211 Newton. Clear or what? Done? ரொம்ப கஷ்டமான question. Okay then. Okay, certain questions in between we should do like this. Clear? So I repeat, children, see, look at this. What task is force by the side wall. Force by the side wall on the water. Force by the side wall on the water. So side wall இப்படி இருக்கும்போது always, you might have studied in inclined plane also, no? All the normal forces will be acting perpendicular to the plane. All the forces will be acting perpendicular to the plane. Suppose if I lean, suppose if I, that will not see. Suppose if I lean on the board, what will happen? I am applying force on the board. Force will apply same and equal force on me. What will be the direction of that force? Normal to this plane. That is the normal force. So if this is of the what, will be the direction force that we will solve in this direction. Opposite side also this way, since we are resolving, components will be cancelled off. So take all the vertical components together. Force due to side wall on the water. So that force is in the upward direction. From the atmospheric pressure, the force will be on the downward direction. Correct? mg, the weight of this liquid will be acting downward direction. This liquid will apply a force on this area. First question was what? What is the force on the bottom area? So when they apply force on bottom area also should apply equal and opposite force. That is the normal force. So that same PA will be acting back. So PA acting upwards, force on due to side wall also acting upwards, force due to atmospheric pressure acting downwards, mg is also acting downwards. Equate it, find the answer. Okay, clear.